Hello everyone, my name is Roy Jafari, and in this video we are going to learn about naive Bayesian as a classification algorithm. While in this video we are not going to cover in extent how naive Bayesian work, we are going to see a good example of naive Bayesian in a real case dataset and how we can actually apply naive Bayesian and makes decisions that are based on the patterns that we have found from the data. So in this video, we are going to build on the video and the prediction we've already done with K and N on the same data set. So if you haven't watched my video about K and N prediction, please stop this video and go watch that video first before coming to this video. So at the end of the video, we'll be comparing the performance of K and N and naive Bayesian in the case study for this video. So let's get to it. All right, so as I said, the first thing we're going to do here is we are going to perform what we already did with K and N here. So we created this function, evaluate binary classification, which we used throughout the previous video. So we're going to keep using this here as well. And this is our data. So these are the lines of code we've already discussed in the previous video. So I'm just going to go ahead and run them. And we eventually got to a point that we were able to do a prediction based on a tuned K and N that gave us a prediction with a better recall than random prediction. So pay attention here. Since this is a marketing campaign that we want to sort of like figure out what are the customers that we want to contact and make sure that what we are doing is we are reaching to the highest maximum possible subscription. Here we want to actually have a maximized recall than accuracy. So that's why we tune our algorithm to get a better recall. That's why we had one neighbor and we use a uniform weights for our tuned K and N. So we also in the previous video we compared this with a random algorithm, random prediction, which we saw that the K and N did much better than the random, and we saw that the recall was actually significantly better. So in this video, we are going to now do the same thing, but this time we're going to use naive Bayesian. So the pre-processing that we did for K and N is going to be a little bit different, and largely is the fact that naive Bayesian does not need a standardized or normalized data. So that's all we have done here. We sort of skipped that step of normalizing, but the rest of them are very similar. So we once we get there, we have our data pre-processed and we have our train and test sets. Now we get to a point that we are going to fit the data into the naive Bayesian model. We are going to use multinomial naive Bayesian from the sklearn module, and this is exactly like the rest of sklearn module. You fit and then you predict. So once we do this, we see that the sklearn, the naive Bayesian, has a very different contingency table. If we were to compare it with the contingency table that we had with K and N, even though we had higher yes for naive Bayesian, but we don't have as much no yes for K and N, which basically tells us naive Bayesian is less frugal on predicting yes, and because there are more cases of yes, we could expect to see a higher recall here. So if we were to compare the performances here, the performance of naive Bayesian is way better than K and N on recall specifically, and also the FS score. But since it's more important for us to have a good recall, we have to pay attention to recall here. The recall is better, but at the same time, we have to be careful about this comparison. Let us compare the number of ones or number of yes predictions each of these algorithms are using. If we compare, we see the naive Bayesian method is basically predicting yes almost twice as much as the other two methods. So for comparing recall, which is our metric of interest here, we have to make sure that we are using the same number of yeses. To sort of remedy this, we can do one thing, and that is going to be using a very specific feature of naive Bayesian. Naive Bayesian is one of the rarest prediction algorithm that with itself comes with a probability of the prediction. Well, I mean, all of the other algorithms could be changed in a way that they can also give you probability, but naive Bayesian, since it works on a principle of conditional probability as a part of the algorithm first finds the probabilities, then does the prediction. So the way the prediction happens is the probability of it being yes or no are found, and if the probability of being yes is higher than 50%, then the algorithm decides it's yes or no, right? So that's the way naive Bayesian works, in very simple terms. So we can actually get those probabilities, right? So these are those probabilities. So this is the probability of the first case being no and the first case being yes. And the summation of these two probability are 1. So if we were to look at all of our data, we can create this summary DF, and also we have sorted them based on the yes probability. We can see that, for example, the probability that was the highest probability, the actual case was actually no, but since the probability is higher than 0.5, we predicted yes. And and so on and so forth. This is the way the algorithm has been sort of like dishing out yes prediction. If we were to want to sort of look at the a good assortment of all of the possible cases here, because we have very large probability of yes probability and very low probability here, we can use the technique of ilog, and then from 0 to 9, 8, 8, 5, 8, 4, which are the indexes of this data frame. And let's look at every 200 row. So once we do that, now we can see all types of probability here. And we can see after we moved from 0.6 and we passed 0.5, now the prediction switched from being yes to no. So we have to find a way to see if we can find a threshold here, that is going to sort of that threshold is going to be if the value or the probability of prediction yes is higher than that threshold, we predict yes, otherwise no. So finding a threshold that is going to give us or use as the same number of yes prediction as the other two methods. That's very important to be able to do this. So to do this, we do this, sort of like loop through possible threshold here, right? So we loop through threshold from 0.5 to 1 and see how many number of ones in those cases we would be using if we chose that threshold. So once we run this, we see if the threshold is 0.5, we are using 2,267. If the threshold is 0.83, we are using 2134 yes prediction. So we can see the threshold that we are looking for, because the number of yes we want to use is around 1,153. So these are very large thresholds. So we switch this from 0.5 to 0.95 and then run this again, and we see now we are lowering the threshold. So we can, let's put a couple of 9s here, and we are getting closer to our goal here, and a little bit more 1153, maybe with one more 9 and see what will happen. All right, so this is 1135. So if we chose this threshold for doing a yes prediction, that's when we have used the same number of roughly the same number of yes prediction as the other two algorithms. So we choose this threshold, we copy it here, and once we do that, now the prediction that we are using for all of them have roughly the same number of, so it was 1135. So let's actually switch this a little bit. So we want 1153. 1153. So this is the number we want. So this is the threshold. Let's run this again. Now we have the same number of yes predictions all across. So now if we were to compare this prediction with the rest of them, it's a fair comparison now for recall. We see that even though we forced in naive Bayesian to use less number of yes prediction, it's still doing a much better prediction as far as having a good recall than the rest of the two methods. It's also doing better on the account of accuracy, precision, and also F-score. So overall, we can see naive Bayesian responded to this case and this problem much better. So in this video, mainly what we did, we quickly went over, we didn't actually go over, we clicked through what we had already done in the previous video, predicting using KNN, and then we applied naive Bayesian to the same problem of predicting if customers are going to be subscribers or not. And we saw KNN, we saw naive Bayesian can do a better prediction in this example. But also along the way, we also took advantage of the uniqueness of naive Bayesian, which is the fact that naive Bayesian comes with the probability for the classification, which is something unique among all of the classification algorithms that we have.